Hi everyone, in this video we're going to be doing questions about carrying onto itself with specific diagrams. In the diagram below, a square is graphed in the coordinate plane, a reflection over which line does not carry the square onto itself. Remember, onto itself means that it needs to look exactly the same as when it started. So all of these answer choices are reflections. So if you notice and look at the answer choices, x plus y is equal to 4. That's not in y equals mx plus b form. So let's subtract x from both sides. Now let's look at our answer choices. The first one, choice 1, is x is equal to 5. So let's go to 5 on the x-axis, which is here. And it's a straight line that goes through the x-axis. So this is x equals 5. If I reflect that, then the square is over here. It's in the exact same place where it started? No, so that's going to be my answer. It does not carry onto itself over a reflection in x equals 5. Let's look at the other choices to make sure we understand why those do, in fact, carry onto itself. So let's look at choice 2, y is equal to 2. So you go up on the y-axis, 2 boxes, and I'm going to draw the line. If I reflect over the line y equals 2, because it goes straight in the middle of the square, it does carry onto itself. So that one does work. Let's look at y is equal to x. So y equal to x goes through the origin and has a slope of 1. So that also carries onto itself. If I reflect it over there, it lands exactly onto itself. So that one works as well. And then if I have y is equal to negative x plus 4, so I have to go up 4 on the y-axis for my y-intercept. And I'm going down 1 over 1 as the slope. So if you notice here, this is going to be your line, x plus y is equal to 4. And that also will carry onto itself. It will reflect onto itself. So therefore, choice 1 is the answer. It does not carry onto itself, and x is equal to 5. It changes the location of the original image. Let's look at the next question. Which transformation would not carry a square onto itself? So this question does not have an image, which means we want to draw one. So let's draw a square. And the key to this question is not. We want to take one that does not carry onto itself. So when I do some type of transformation, it doesn't land exactly onto itself. It doesn't look exactly the same as when it started. So let's look at the first one, a reflection over one of its diagonals. Well, that makes sense because if I drew a diagonal there, because it's a square, it would reflect onto itself. So that one would work. If I rotated 90 degrees about its center, if I pick any about its center, so that it would be here. If I turn it from the middle, that means it would look exactly the same. So that would work as well. Remember, when you're turning something 90 degrees, you can turn the page. Let's see, if you're rotating something 180 degrees from one of its vertices. So remember, its vertices are just the corners of the square. So let's say I'm going to turn it from here. That means the new image would be here. It would not be onto itself. So that's going to be our answer. And then number 4, a reflection over the perpendicular bisector. That would also make sense. It would fold onto itself because it cuts it in half and it would fold onto itself. Let's look at the next question. As shown in the graph below, the quadrilateral is a rectangle. Which transformation would not map the rectangle onto itself? So again, this is another not question. So we have to go through all the answer choices. So 1 says a reflection over the x-axis. So here's the x-axis. If I reflect it over itself, it lands onto itself. So we know that one works. It's cutting it in the middle. Next one, a reflection over the line, x is equal to 4. So I go to 4, 1, 2, 3, 4 on my x-axis. That's going to be a vertical line. And again, that's cutting it in half, so it would reflect onto itself. a rotation of 180 degrees about the origin. So the origin is here, and if I reflected it 180 degrees, it would look like this. That is not onto itself. It's in an entirely new location, so that's going to be our answer. Let's verify that choice 4 doesn't work. A rotation of 180 degrees about the point 4, 0. So that's 1, 2, 3, 4. If you look at 4, 0, that's in the middle of the rectangle. So if I take that and I turn that 180 degrees, it's going to land onto itself. So that one also works. Obviously, choice 3 doesn't work because we're rotating about the origin, 0, 0. That's not inside the rectangle, so that's why it's going to change the location entirely. Let's look at the next question. The figure below shows a rhombus with non-congruent diagonals. Now, let's remember a rhombus has all congruent sides. Which transformation would not carry this rhombus onto itself? So again, this is another not question. So let's go through the ones that do make sense. A reflection over the shorter diagonal. So let's say this is the shorter diagonal. If we reflect over, it's going to go onto itself. So that one works. Then a reflection over the longer diagonal. That's also going to work because if you reflect it over, because the sides are congruent, that would reflect onto itself. How about 3, choice 3, a clockwise rotation of 90 degrees about the intersection of the diagonals. So the intersection of the diagonals would be here. Now remember, if I turn something 90 degrees, I could take my piece of paper and turn it once. That image is going to look different than my original image, so that's going to be my answer. However, choice 4, a counterclockwise rotation of 180 degrees about the intersection of the diagonals. If I take my piece of paper and turn it once and then twice, it's going to look exactly the same. So that's why it's choice 3, when you turn it 90 degrees about the origin, or the middle, I should say, not the origin, the intersection of the diagonals, it's going to look different. The next question says, which transformation carries the parallelogram below onto itself? So this one is onto itself. We want to know which one actually works. So why don't you take a look at the answer choices. 1, a reflection over y is equal to x. A reflection over y is equal to negative x. A rotation of 90 degrees counterclockwise about the origin. Or a rotation of 180 degrees counterclockwise about the origin. Now remember, this is a parallelogram, so the sides are not congruent, only the opposite sides are congruent. So that means the answer is going to be choice 4. If I've rotated 180 degrees, if I take my piece of paper and turn it twice, it's going to look exactly the same as when you started. 90 degrees, if I turn it once, it's not going to look the same. If I reflect it over y equals x, which is right here, it's not going to be the same. And if I reflect it over y equals negative x, that won't be the same either. So turning it 180 degrees about the origin is going to have it look exactly the same as when it started. Let's look at the next question. A rhombus is graphed on the set of axes below. Which transformation would carry the rhombus onto itself? So we want to know which one would work. Is it a rotation of 180 degrees counterclockwise about the origin? So here's the origin. If I rotated 180 degrees from the origin, it's going to be down here. So that's not going to work. Next, if I look at a reflection over the line 1/2 x plus 1. So here's plus 1, and I have to go up a half. Up 1, over 2, down 1 over 2. This is going to be your line. If I reflect over that line, it's not going to work. It's not going to lay exactly on top of each other. So that one's out as well. Then how about a reflection over y equals 0? Well, y equals 0 is the same thing as the x-axis. If I reflect it over that, that's not going to work. And lastly, a reflection over x equals 0, that's the y-axis. That makes sense. If I reflect it over that, that's going to work. Lastly, let's look. In the diagram below, rectangle ABCD has vertices whose coordinates are A, 7, 1, B, 9, 3, C, 3, 9, and D, 1, 7. Which transformation will not carry the rectangle onto itself? So again, this is a not question. So we're looking for the one that does not work. So let's look at the first one. A reflection over y equals x. So remember, y equals x, it goes through the origin, up 1 over 1, up 1 over 1 as the slope. And it appears as though it's cutting the rectangle in half, so that will work. Next, let's look at the next choice, a reflection over y is equal to negative x plus 10. So I want to go 10 in my y-intercept, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then because my slope is negative 1, I'm going down 1 to the right 1, down 1 to the right 1. And this also appears as though it's cutting it in half and reflecting onto itself. So that one works as well. Then a rotation of 180 degrees about the point 6, 6. So let's find 6, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. If I rotate that 180 degrees about that point, the figure is going to be over here. So that one appears as though it's not going to work, which means it's going to be my answer choice. Let's do the last one just in case. A rotation of 180 degrees about the point 5, 5. So let's find 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That looks like it's in the center of the rectangle. So if I rotate that 180 degrees because it's in the middle, it's going to be in the exact same spot. And there you have it. Those are questions about carrying onto itself with diagrams.